Hello, good morning, everyone. So yesterday we discussed about static routing. So you can configure static routing in three types. First one was directly connected. So for directly connected static route, you use the exit interface. So it is IP route. Network IP, subnet mask, and exit interface. Then we discussed about recursive static route. Yes. So here you will be mentioning the next step. So it's IP route, network, subnet mask, and the next hop IP. So then we used fully specified static. So in fully specified static route, we'll be mentioning both exit interface and the next stop. So this we discussed yesterday. So today we'll be seeing what are the disadvantages of static routing, why we moved on to dynamic routing protocols.
No, apart from that disadvantage, can you just, you said third way is the best one, right?
Because it in the routing table, no, you have both the entries. Both your next stop will be present and the exit interface is present.
Is there any technical answer? Because I search in Google some ARPU, I didn't understand because I read it. If somebody asks us, then how we can answer them?
Means?
Like, what is the disadvantage to add only the exit interface or next hop? In
exit interface, your ARP entry will not be there. Those exit interface are mainly used on the serial links.
What do you mean by ARP entry?
What do you mean by ARP, first of all?
ARP, we got the ARP for the next hop. In our interface, we got the two ARP entries. One is a local, one is a next hop.
Why we use ARP?
To process packets.
To process packets?
Like to send the packets.
Send the packets. It's a layer 2 protocol that is used to resolve the destination MAC.
Yes.
With the help of?
From known IP address.
With the help of known IP address. Correct?
Yes.
So if we talk about exit interface, no? So why we use exit interface? So what I mean by exit interface is, it is directly connected. So it treats as the route which you want to reach as directly connected route. That's right. Why we don't have what is a recursive lookup here in exit interface. Correct?
Okay.
Because we know where to exit from, right?
Okay.
So what about next hop? When we use next hop, what happens?
In that case, we have ARP.
Yes. What
In
happens
that case,
next hop?
we have recursive lookup will happen.
Tell me.
In case of next hop, recursive lookup will happen.
Recursive lookup will happen. Why?
Due to ARP entry.
Due to ARP entry, right? Or in the routing table, what it shows? The next hop as, let us consider it as 192.168.12.2. But what about the exit interface? I don't know the exit interface, right? Again, I need to look into the exit interface with the directly connected route. So we are doing double lookups here. What about fully specified? So we're mentioning both the exit interface and the next hop. So both are mentioned here so that whenever any router wants to reach to the destination network, what it will do? It will not do any recursive lookup because it knows where to exit from and what is the next hop as well. Clear?
Okay. Okay.
Second point. So if you have a topology, let us consider we have R1, R2, we have R3, we have R4, and we have a loopback 4.4.4.4/32. Now, so this is, let us consider 192.168.12.0/24. We have 192.168.23.0/24. This is 192.168.24.0/24. We have 192.168.34.0/24. This is 192.168.23.0/24. Now the problem with the static route is, let us consider I want to reach the loopback IP. So now this is .1, this is .2, this is .1, this is .3, right? Now you need to provide the next hop, or if you provide the fully specified also, you need to tell the exit interface and the next hop IP. Let us consider I have provided. What R1, R2, R3? Which one? Topology you didn't understand? What is there in topology? We have 4 routers and we have 1 loop. Yes. Now I'm talking about if R1 wants to reach to 4.4.4.4. With the help of static routes, what you will do? You need to go and configure manually on the R1. What will be the next hop? You need to provide a next hop and exit interface. It may be either R2 or it may be either R3, correct? Let us consider we have used R2 as the next hop and I have provided the exit interface Z0 bar 0. Now the problem is, let us consider this link has gone down. Now you will never be able to reach to the 4.4.4.4 because what is there in your routing table? What is the next hop? It is 12.2. Now you need to go and manually change the next hop on R1. Means there is no backup path in static routes. Clear? We can't create backup paths in static. So you need to go to R1 and manually change the next hop IP. Clear?
What happens if I mention both the groups?
Means?
12.1 and also the routers.
It will take 12.1 first and then 23. It depends on the first one first.
So it comes. So in If the R2 doesn't perform, it comes to R2.
No, that will not happen. You can check once.
Why is it?
Because you need to provide the AD value, something like floating static route, you need to clear again. You have more type of static route. But see, let us consider you have configured the backup path as well. So how many entries you need to have on R1? You need to create multiple entries here. So when R2 you need to go, how many links we have? Let us consider I have a loop back here as well. So let us consider on R2, you have provided the next hop as R1. Now, if this link fails, you need to provide this as well. How many static entries you create? You need to create multiple static entries on a, what is a particular router. That's why we use the concept of dynamic vector routing protocols. So they will dynamically find the best path to reach to the destination. Clear? Okay. So
if you are not, if R1 or R2 server is down, so we can't reach R4, right?
no,
So in that case, what we have to do?
no, you need to go and manually change the next hop.
Manually, we have to check it. The example, if we have to create multiple this one IDs, IP addresses,
Multiple IP address means?
IP routes.
Okay.
So in that case, is it possible?
It is not possible. You can go and check once. It's not possible. Okay. So now,
Sir, can you tell me once yesterday topologies exiting interface, how to find that? I just confused that one.
which one?
Yesterday topology between R1, R2, R3, exiting interface, how to find?
How to find exit interface? This is 192.168.1.0/24, 12.0/24, 23.0/24, 168.2.0/24. Tell me. So now let us consider, I want to create a static route on R1 to 23.0 network. What will be your exit interface? Where it is exiting from?
In G0/1 or?
Now that only I'm asking you. So in
Yes.
order to reach to 23.0, will you go to G0/1 or G0/0?
G0/0.
Correct, right?
Yes.
That is, let us consider on R2. I want to create a static route for 192.168.1.0.
Okay.
From where you are going, G0/0 or G0/1?
G0/0.
Why is G0/1? Your network is here, right?
Yes, yes.
Then what you are exiting from? G0/0.
Okay, okay. Now understand. Thank you.
Okay. Now, dynamic routing protocol. So what do you mean by dynamic routing protocol? It is used to dynamically or automatically find the best path or optimal path to reach to the destination. So in dynamic routing protocols, so in your syllabus, we have two protocols, that is EIGRP and OSP. So we'll be starting with EIGRP. We'll finish off EIGRP and then we'll start with OSP. So before EIGRP, we had a protocol called IGRP. Interior Gateway Routing Protocol. Now the question is why they came up with EIGRP. It is enhanced, it's just enhanced. Why? Any idea? Because if we talk about IGRP, it supported only class 4 networks. The second major disadvantage was it doesn't support authentication. And third disadvantage was no manual summarization. You can't do any manual summarization while using IGRP. No manual summarization. So these were the three disadvantages in IGRP. Why they moved on to EIGRP? Enhanced Interior Gateway Routing Protocol.
The second word support.
It doesn't support authentication. No? No. So EIGRP, earlier it was a Cisco proprietary. When it was introduced, it was a Cisco proprietary. So after 2013, they made EIGRP as open standard. We talk about the AD value, it is 90 and 170. So 90 is for internal and 170 is for external routes. Means redistributed routes. And it uses dual algorithm to find the best path. What is the protocol number of EIGRP?
$88.
88. It works on the protocol number 88. Which layer of OSI? Network layer. And it uses multicast address. Two 24 0 0 10. Done? One of is done. Next point, it is a distance vector routing protocol. Any idea why we call distance vector?
It is selected lowest distance.
Least distance. What I mean by distance is how far away is your destination. It will tell you how far away it is. Your destination is. And vector means it will tell you the direction as well. So maximum hop counts. EIGRP supports is 255. But by default,
100.
100.
What is mean by this vector and direction stand for?
Vector means it will tell you the direction. It will tell you the distance, means how many hops away is your destination and in which direction I should go. I should go in this direction or I should go in this direction. That's why we call it as distance vector. Clear?
Yes, sir.
So now, so these are few of the points of EIGRP. Now, so now if you want to completely understand about EIGRP, we need to understand three tables. So we have three tables in EIGRP. So we have topology table, we have neighbor table, and third we have routing table. Now, so if we talk about EIGRP neighbor table, so what we'll find here, we'll find list of all directly connected neighbors. Next hop, router. Third point is you get the interface as well, where you need to exit from. You'll find these three informations in the neighbor table. List of all directly connected neighbors. So in topology table, it contains all learned routes from all EIGRP neighbors. You'll find the destination as well. And third point, you'll find the metric. That is your feasible distance. So we'll talk about the metric later. So in routing table, you will find the best path taken from the topology table. No? No. So now, if you talk about how EIGRP will calculate the best path, it is the feasible distance. And EIGRP is rich in metrics. So if you talk about the metrics they will use is bandwidth. Sorry, we will not call it as metrics, we will call it as attributes. So we have bandwidth, delay, load, reliability, and MT. So in order to find the best path, it will use all these attributes to select the best path. So if we talk about the formula, how it calculates the best path. So the original formula is feasible distance. FD stands for feasible distance. This is the metric that EIGRP calculates. It is 256 into K1 into 10 to the power of 7 divided by minimum bandwidth plus K2 into 10 to the power of 7 divided by minimum bandwidth divided by 256 minus load plus K3 into sigma delay by 10 whole multiplied by K5 by K4 plus, sorry, K4 plus reliability. So this is the formula it uses to calculate the best part. So the reason why we multiply this by 256 is because our EIGRP was 24-bit metric. So if we talk about EIGRP is 32-bit metric. So the difference is 8 bits. So we multiply 2 to the power of 8, that is 256. So this is the formula it uses to calculate the best path. These are K values. I'll talk about this K values. So K1 is bandwidth. K2 is load. K3 is delay. K4 is reliability. And K5 is empty. So these are the key values. So by default, we use K1 and K3. So load is kept as 0, reliability is kept as 0, and MTU is kept as 0. Sorry, it is not 3, it is 1. Now the question is why? Why only they use bandwidth and delay? Why not load, reliability, and MTU? Even Cisco recommends the same. Yes. Why only K1 and K3? Why not K2, K4, and K5? Why not load? Why not reliability? And why not MTU? Any idea? Yes, online guys. Because your bandwidth and delay are static values. And your load, reliability, and MTU are dynamic values. What do you mean by dynamic values?
Can be static.
Yes.
MTU can be static, right?
MTU is 1500, right?
No. That is again a fixed value. It will not change, right?
It will not change, correct. But we call this as dynamic values. But we still don't use MTU part. Because jumbo frames, anything above 1500, again, you need to, what you say? You need to adjust your MTU, right? So in order to allow that particular jumbo frame. So that's why we also consider MTU as dynamic value. Because your router will drop a packet if it is more than 1500. By default, it is 1500, right?
Yeah.
Yes. So these values change over time. And static values remains constant over time. Now, when you substitute these values, so the formula will be, so K1 will be 1, 0, 0. So our formula reduces to 256 10 to the power of 7 divided by minimum bandwidth plus K3 is 1, sigma delay by 10. Sigma delay means total delay. This is the formula. So by default, EIGRP uses bandwidth and delay.
Sorry to say, like your voice sometimes it breaks. Even yesterday,
Internet issues.
even in the recorded video when I listen it,
Yes. That is because
it have some issue.
Yes, internet. Internet issue is there. Sometimes. Yeah. Now it is okay. Yeah, fine. Sometimes, right?
Yeah, sometimes.
Yeah, yeah. This part is clear now. So now we'll see the mechanism how EIGRP will calculate the best part. Now, let us consider we have three routers. R1, we have R2, and we have R3. So we have a network 3.3.3.3/32. Let us consider the feasible distance. Value is 5, FD is 10, and FD is 5. Now, so you have two terms you need to understand. One is advertised distance, not administrative distance. Don't confuse with that. We have advertised distance, or we also call it as reported distance. And we have feasible distance. So you need to understand these two terms. So advertised distance is also called as reported distance. So what do you mean by advertised distance or reported distances? It is the neighbor's distance to the destination. So what do you mean by feasible distance? It is the total distance from source to the destination. This AD and feasible distance you will see in the topology table. Again, distance table. Okay, now. So now, if you talk about from R3's perspective, what is the AD value? That is advertised distance. Advertised distance will be 5. In order to reach to 3.3.3/32. It is the neighbor's distance to the destination. So this will be advertised to R2. Now, based on the AD value, R2 will calculate the total distance. That we call it as feasible distance. What is the feasible distance? It is 10 plus 5, 15. No?
And you mentioned FD feasible distance is a total distance from
Yes.
source to destination,
Totally.
right?
I'm talking about the R2's perspective.
No. There is one FD you mentioned on per link. FD is 5, FD is 10, FD is 5. What
It
is
the
that?
calculation, metric. Okay. Remove this FD and tell metric. Metric.
Okay.
Confusion. Clear? No. Well, what happened? Nothing? No. So from R2's perspective, what is the AD to reach R1? AD value. What is the advertised distance? AD from R2's perspective. Sorry, from R1's perspective. What is the AD? In order to reach to 3.3.3.3. 10 plus
20.
15. 50. Correct, right? So what is the AD value? Is the neighbor's distance to the destination. What is the distance, total distance? It is 50. So it will advertise
15.
AD of 50. Now, what is the total distance? Yes. Like this, EIGRP will
FD 20.
20. Yes. Total distance. Clear? Any doubts in AD and FD? Yeah? No. Any doubts online, guys?
So is AD and FD information will show on CLI as well when we
Here. Topological.
cover the table. Okay.
Yes. I'll show you when we do the lab. Okay. Clear? Now. So now you need to understand two more terms. We have successor and feasible successor. So what do you mean by successor? So it is loop free. Best path. To reach to the destination. Now, what do you mean by feasible successor. So it is also loop free. Very second best path, or we can call it as backup path. It is also loop free. Second best path, or we can call it as suboptimal path. Second best path, we can call it as backup path. To reach to the destination. So successor is only present in your routing table. One note. So both your successor information and feasible successor information is present in your topology table. So what do you mean by this? So both your successor and feasible information you will find in the topology table, but in the routing table only you will find the successor. Means the best path to reach to the destination you will find only in the routing table. So once the successor goes down, then your feasible successor will act as a backup path. And this is only there in EIGRP. We don't have any backup path concept in OSP. Now we'll see how it elects a particular path as a successor and feasible successor. So let us consider we have R1, we have R2, we have R3, and we have R4, and we have R5. Let us consider we have the destination. Let us consider the metric. I'll write MET, okay? So 5 and 10. 5. Metric has 5. Metric has 9. And metric has 100.
One more thing. So this metric will it get from the delay and the bandwidth, right?
Yes, yes.
Is there any command we can just set a metric with simple line, or we need to define the bandwidth and delay?
You can use summary metric command. We have.
Sorry.
So what you are telling, how to set the bandwidth and delay?
No, like bandwidth, I think it will calculate from the interface bandwidth, right?
Yes, yes, yes.
And delay, how it will calculate delay?
Yes, it is a total delay to reach to your destination. It will consider. Let us consider the delay as 5 here. Delay is 5. It will take the total delay into consideration, right?
Okay. So delay, it is like TTL to reach to the hop to hop. That delay you are talking about, right?
Yes.
Okay.
Now. No, from R1's perspective. So what is advertised distance? What is the feasible distance? So from R2, what is the advertised distance? Yeah. From R3, what is the advertised distance? 5. What is the advertised distance from R4? It is 100. So now what is the feasible distance? It is 15. It is 10. It is 109. Sorry, 1 minute. Small change. Very sorry. This is 100. And this is 9. Now, sorry. This is 9. This will remain 11. Now tell me, who will become the successor? Least best path. So he will be the successor. Now tell me, who will become feasible successor? Whether R4 path will become the feasible successor or R2's path will become the feasible successor.
R2.
No. Okay, R2. Why? Correct. Why? Next best path? No. Again, in order for a route to become the feasible successor, it should satisfy a feasibility condition. So now, feasibility condition. There is a condition here.
So as you told, the
Least best path. Yes, this is.
Yes. The comparison will be least best
Yes,
path
yes,
comparison.
yes, yes.
So because R2 is a it's a feasible
Yes,
thing, right?
yes, less,
So
least compared.
Yeah, R4 is a 109. So
Yes.
how come will be R4 will be a
Come here. Feasibility condition. There is a condition for a route to become the feasible successor. What is the condition? So the advertised distance of feasible successor should be less than feasible distance of the successor. Now check the condition. Advertised distance of feasible successor should be less than feasible distance of the successor. So he will become feasible successor. Why? Compare these two values and compare these two. What I'm saying here, less, not equal to. In order to become a feasible successor, the advertised distance should be less than the feasible distance of the successor. Not clear? Okay, come back. Read the statement once again. What the statement is saying, advertised distance. Okay, this is my advertised distance, correct? This is advertised distance. So in order to become a feasible successor. So now I want to elect a feasible successor, right? Either R2 will become a feasible successor or R4 will become the feasible successor. Correct. So what is the condition? That should be advertised distance should be less than the feasible distance of the successor. What is the feasible distance? 10. Means this advertised distance should be less than 10. So if we talk about R2's value, it is same, exact, right? So I will not elect this path as the feasible successor. If you talk about this value is lesser compared to your feasible distance of successor. That's why it will elect this path as the feasible successor.
The value should be
Not equal as well. Yes, it should be less. Can you see it? Less. Should be less. Now clear? So many are there to remember like this.
Sir, in case if R4 also had an AD of 10,
10.
then in that case,
No feasible successor at that point of time. Only successor. It must satisfy this condition. If it is not satisfying this condition, then your backup path will not be installed in your topology table. It must satisfy this condition.
any chance that two rules that is equal to this,
Yeah.
So
Load balance. Load balance. I'll show you. We have equal cost and unequal cost load balance. That time I'll show you. I hope this part is clear. So anybody has any doubts? Till here? Yes, online guys. Is it clear? Clear? Okay. Now we'll talk about EIGRP packet types. We have 7 EIGRP packet types. So we have hello. We have update. We have query. We have reply. We have acknowledgement. We have SI query. And we have SIA reply. So these two we'll talk later. So we'll take a dedicated class for discussing SI query and SI reply. So now we'll discuss about these 5 packet types. So now, why hello packet? So first packet, it is used to form and maintain, or we can call it as establish and maintain neighbor adjacency. Membership or web adjacency.
How come like in hello is just like first it will send the hellos, right?
Yes.
Then how come it is used to maintain and
Every
establish?
5 seconds it will send. After that, first it will form the establish the adjacency. Once, let us consider we have two routers. Sorry. 1 minute. 1 minute. We'll come back to that question. So now how will maintain, right? So now see, let us consider we have two routers. So I enabled EIGRP in both the routers. So R1 will send a hello packet, R2 will send a hello packet. Now it has established the neighbor adjacency. Now how will know R1 is alive and R2 is alive? You don't have any mechanism, right? So this is the mechanism. So every 5 seconds, it will send a hello packet
So
just to
is it
say they are alive.
okay? Is it vary from like in the WebSphere we have multiple types of?
No, it will not vary. It is the constant.
Okay, it's 5 seconds, right?
5 seconds, yes.
So that value is fixed. We can't change it.
You can change. You can change. We have what to say. We have a command to change. Even you can change the whole time as well. So hello is 5. This is by default. And hold is 15 seconds.
Sir, for hello response, we also get a hello from far side.
Yes.
Is it so?
Yes. If you enable
is there
EIGRP on both the sides.
Okay.
Yes. Then how you will form the neighbor adjacency, right? So I am saying you hello. You need to say also hello, right? Then only will form the adjacency. So why we call it as maintaining? How I know that you are alive? You are alive or dead? So every 5 seconds it should send a hello packet.
Keep alive. Is it a
Like
keep
a
alive
keep alive mechanism.
message?
Very good, very good, very good. It's like a keep alive mechanism. In BGP we have keep alive, separate we have. We'll talk about BGP. So now if we talk about update packet, it is used to exchange the routing information. So when use a query is when a particular router has lost its successor and feasible successor. Lost the successor and we don't have a feasible successor in the topology table. Then the router will start querying. So reply. Reply packet, it is sent. So any other word for reply? Reply. I'm replying to you. Any other word for this reply? Backup.
Response.
Response. Very good. It is sent in response for a query. So acknowledgement, since EIGRP is reliable, so you will get acknowledgement for update, query, reply, SI query, and SI reply. Acknowledgement for for update, query, reply, SI query, and SI reply. These 5 packets we call it as reliable packets. Very important for interviews. So whenever you send an update, you will get an acknowledgement back. Whenever you send a query, you'll get an acknowledgement. Whenever you send a reply, you'll get an acknowledgement, even for SI query and SI reply. These packets, we call it as reliable packets.
Overall, for everything, whichever we sent, we got a reward, right?
Yes, no, except hello and acknowledgement. For hello,
No, hello,
hello,
we also got hello from other end, right?
Yes, that is not an acknowledgement, right? So let us consider it was doing that. Let us consider we have R1, so R2. Okay, now it has sent a hello. Now it has sent an acknowledgement. So every 5 seconds it should do, right? Correct? Every 5 seconds your hello is sent. Means acknowledgement, again acknowledgement. So that's why for a hello, you will never get an acknowledgement back. I will show you in the what is say debug. Only for your update, query, reply, SI query and SI reply, you will get an acknowledgement. Clear? So anybody has any doubts still here? You can ask me. I'm done for the day. Yes, guys. Anybody has any doubts?
Mechanism how to EIGRP to calculate the best calculator, right?
Mm-hmm.
The R1 and R2, R3.
Mm-hmm.
That's a 3.3.3.22.
Mm.
So why
Correct.
is 3.3.3 in that?
What? Okay, 1 minute. Okay, 1 minute, guys. One doubt is there. Yes, tell me.
Mechanism how.
Oh, mechanism. Okay.
EIGRP calculate the best.
Mm.
So in that, advertise distance and everything is fine.
Okay.
So
What you didn't understand?
I want that. Why you have to take a 3.3.3?
That is the loop back I have created just. Not only 3.3, you can create anything there. Just, it is a loop back I created. For example. Yeah. See, I showed you the destination, right? In another example. So instead of destination, I used the loop back. Janendra, I have sent you, I have added you yesterday. Please provide me your email ID. I hope everybody has got the link access. So if anybody has not got, let me know their email IDs. I will quickly share that. I hope yesterday I have shared your Janendra. So 8 to 10 AM, right? Or this one. Sorry. Okay. So 18th, 19th is done. Okay, I think I have shared with Janendra. Janendra.arya, right? Jenny.
ARY.
Coming on the screen. I hope everybody has got the link access. Let me know who has not got the link access. Yes, guys? Everybody has got? Okay. Thank you so much, guys. Have a nice day. Bye. We'll meet tomorrow.
Thanks.